Hey Zach, did you get 1/8 for the expectation?
Yeah, Ojus. 1/8 for the expectation, but I'm not sure. Part B's variant. John, what'd you get for the variance?
I got 1/16. Is that what you got?
Yeah, that's what I got.
Awesome, we're done.
Fantastic. Whew, that was a really tough problem set, guys. Isn't our major declarations due pretty soon?
I'm looking at chemical engineering. I really like chemistry in high school, and I think the math will really intertwine very well.
I was thinking about biological and environmental engineering, but I'm not really sure if it's right for me.
We really got a lot of time to decide. Don't we have to turn in this problem set like right now? Probably better go.
All right, let's roll.
Oh, wait, 1 second. I forgot some stuff from my research. We gotta stop by.
Oh, shiz.
All right, well, let's go.
Hey, Adrian. I actually had a question for you. I'm facing some aggregation of my nanoparticles. I was wondering if you could help me out.
Is your glassware clean, and what order are you adding the surfactant to the nanoparticles?
Oh yeah, my glassware is great. Mr. Clean would approve. I'm not too sure about the surfactant though.
All right, so here's the deal. If you're adding the surfactant into the nanoparticle suspension, you'll probably get aggregation.
Whoa. Where'd you guys learn about this?
I'm a senior studying material science and engineering. Material science, you're like a mechanic, all the way from the quantum scale to big buildings and cars.
Wow, well, that actually sounds like a really broad field. So I guess, what are you into? What do you do with it?
So I chose to study material science and engineering because I wanted to work on atomically precise manufacturing. The company I worked with this past summer is actually working specifically on that project, and they're commercializing it. And because I was a student here at Cornell, I was able to find that opportunity.
So I presume you're going back there next year?
Correct. First a PhD, and then I'll work with them.
I actually have to finish up the problem set that we're working on, but I'll get in the lab later today, so I'll probably see you later.
See you later.
Oh, thanks, Ojus. Oh, hey, Billy, what's up?
Great, I'm just finishing up work on my AEW here.
What's an AEW?
Well, it's kind of like...
It's a supplemental class for people transitioning from high school to Cornell. They can take it if they want, just to help out on the side of their classes.
Oh, wow, so are you the instructor?
Yeah, my name's Virginia. I'm actually a senior in electrical and computer engineering.
What exactly is ECE, and how have you found the course load so far?
Well, ECE is sort of the combination of two different things. You have electrical engineering, which is sort of the wires and the everything that makes up the inside of a toy car or something, and then computer engineering, which is what makes up your digital watch that you wear. And the course load, I mean, it's been difficult. There's a lot of work to do, but you get by making groups of friends to work together, and I've still found plenty of time to get involved outside of engineering on a lot of different campus activities.
Well, that's awesome. Well, what exactly are you involved with on campus?
Well, I actually joined a sorority my freshman year, and then now I'm the executive vice president of the Panhellenic Council, which oversees all the sororities on campus.
So why did you choose ECE?
Well, I actually came in as the applied engineering physics major, but then I sort of figured out that it was a little too research intensive for me. Started talking to all the different deans of the colleges within engineering, and when I came around to the ECE dean, he told me about the really cool upper level design courses that all of the ECE majors take, including building a laser, building a pinball machine was a project of one student, and I just sort of fit right in.
Well, Billy, we were going to turn in our homework. You want to come with us?
We actually got to finish up here, but I'll be sure to print off your guys' cover sheets and give you a call to meet up.
All right, it was nice to meet you. See you later, Billy.
Take care.
See you guys.
Hey, how you doing, man? This is actually my orientation leader. This is Zach, Ojus.
Hey, how you going? Nice to meet you.
Hey, how's it going?
We were wondering if you could just tell us a little about the major.
Yeah, sure. Operations research to me in one line, using mathematical tools to make business decisions.
I had never heard of operations research. How did you get involved?
I started off with computer science, but you know, you guys probably all took intro to engineering courses as freshmen.
Yeah.
So the one I took was operations research, and it allowed me to kind of look at the mathematical background required in this major without committing.
All right, well, we have to turn this homework assignment. It was really nice. Thanks for the input, man.
All right, get the homework in.
Thanks so much.
You guys.
Yeah, nice to meet you. Take it easy.
Oh, that's really cool. What's in there?
Hey, do you know what this is?
This is the machine shop here. So if you're in mechanical engineering, one of the main classes is conducted mainly in the machine shop.
Hey, what up, man? How you doing?
Hey, JP, how's it going? If you want to know more about mechanical engineering, JP here is also in the major, and he's actually the team leader for the FSAE project team.
You guys want to come down to the Carton office? I'll show you around and come in a rush. Yeah, absolutely. Right, let's go. Cool. Each project team is designing and building, a certain type of project. There's a submarine team, there's a Baja team that do like an off-road car racing. We're FSAE, we do like a race car and we race every year. And the sweet thing is that teams get up to like 50 students and it's all student run. And it's like actually tackling real life problems. So there's a lot of companies that think that engineers, after doing 4 years of project teams, is the same as an engineer without doing a project team and with 2 years of experience in the job.
Hey, what's up, Billy? Yeah, we can meet pretty soon.
Alright, before you go, take a look at the car.
Whee!
No, it looks good.
Oh, hey, Billy. What's up?
Oh, hey guys! Oh, I have your cover sheets here.
Oh, thanks,
Yeah,
man.
you bet.
Thanks.
Printed that right out for
Fantastic.
you.
Yeah, awesome.
I'm just working on some MATLAB with Jeff here. Do you guys know Jeff?
No.
Actually, don't.
Hey, what's up, man?
I'm John.
Jeff, nice to meet you.
Oh, cool. So, Jeff, do you actually study computer science?
Yeah, so I'm a senior College of Engineering, computer science major.
Well, how did you end up deciding on going with CS?
So in high school, I was big into web programming, web design, and I was making Flash games.
So your time at Cornell, have you been able to be involved with any interesting projects?
Right now, I'm working on a way to recognize faces by solving a large system of linear equations. That was cool. I also implemented Google's PageRank algorithm in a clustered computing setting.
So what do you plan on doing after college?
So basically there's this interesting field which is called quantitative finance. And what that means is basically the application of computer science, mathematics to financial markets and products. Oh, finally, thank you. Okay, this works. We're done. We're good. Let's get out of here.
Thank you, Jeff.
No problem,
Thank you
man.
so much, man. I really appreciate it. I guess I'm done here. I guess we can go head out, grab my cover sheet there. We can go turn in our problem set together.
Fantastic.
Get out of here.
Awesome. Thanks, Jeff. Appreciate it.
Take care.
Jeff. Nice to meet you. I'm so excited to turn this cover sheet. Ojus, where have you been?
Oh, I lost you guys at the SAE lab, but I actually got here and handed in my homework before. And now, actually, I'm talking to Dara right now about sustainability at Cornell.
Could you tell me a little bit more?
We're a project team that grew out of Cornell Solar Decathlon, and now we have 2 projects, a schoolhouse that we're building in South Africa and a sustainability research lab on campus.
Wow, that sounds really cool. What's your major?
I'm a senior civil engineer, and I have a concentration in structures.
What do you mean by concentration?
In civil engineering, there are 3 concentrations: structures, transportation, and environment. So essentially, after you've taken intro classes in all of them, you can choose to take your upper level electives in only one.
That's really interesting. Well, I think it's lunchtime, guys, so I'm getting pretty hungry.
Well, it was very nice meeting you.
Oh, Sharif, what's up? Hey, guys, this is the TA in my computer science class.
Computer science TA? I thought you were an operations research engineer.
I am. I'm an OR, but I am a minor in CS as well. And if you do well in a class, you can be a TA in any class.
Wow. Is it a lot of work having both a major and a minor?
I wouldn't say it's a lot of work. Being an OR and CS, there's a lot of overlap in the classes. And I'm also very interested in CS. So taking those classes outside of my major is something that interests me, and it makes the workload seem less heavy.
Is that how you ended up getting your job with Microsoft?
Microsoft? Whoa!
Yes, Microsoft. And it was actually pretty easy. After going to the career fair, submitting my resume, they come back and give you on-campus interviews. You don't have to fly out there if you don't want to.
That's really cool. Well, are you headed back to Microsoft after you graduate?
Yeah, I'll be headed back there this upcoming summer. All right, so it's nice meeting you guys. I gotta run and turn in this homework in Thurston.
It's nice meeting you.
See you guys later.
Yep, take it easy.
Hey, Will!
Hey, Ojus, what's up, dude?
Hey, this is Will from the Cornell Satellite Project.
I didn't even know Cornell had a satellite project. What is that?
Yeah, we do. We're part of a contest with other universities, and when we win, we get to, it'll be launched into space. So we won 3 years ago, and this is kind of the next iteration. Sounds great. How'd you get involved with that? Well, actually, I did a co-op last summer in Space Systems Morale in California and really liked it. So I look for opportunities for aerospace engineering here on campus.
So could you actually remind me what the co-op program is and how it works?
A co-op is kind of like an internship on steroids. Instead of just over the summer, you also go for a fall semester. So it's full 28 weeks of working, and you also have to do your junior semester in the summer. So you're not behind in your classwork, but you still get 28 weeks at a workplace.
That's really awesome. What's your major?
Oh, I'm an applied engineering physics major. So what is applied engineering physics? Actually, it's kind of a blend between a lot of different majors, and it kind of looks at each of them at the very low level of engineering. So we learn about E&M, we learn about mechanical properties, we learn about dynamics of solids, and we kind of combine those to kind of build a foundation of engineering knowledge that we can apply to other situations. So for example, I was really interested in combining electrical and mechanical engineering and the properties and what needs to be known to kind of interface at that level, at a very low level. And so engineering physics provided a platform for me to do that. So for example, like right now I was building some robots. Robots? Patrick! The Big Red Bear!
What'd you get for the variance?
I got 1/16. Is that what you got?
Yeah, that's what I got.
Awesome, we're done.
It's not like we're big.
Oh, hey guys.
Billy, have you been asleep this entire time?
I guess so, but I had the craziest dream and you all were in it. But are we done with the problem set? What's the
Problem set?
What problem set?
Billy, what are you talking about? We don't have time for dreaming. Our major declarations are due today. Here, fill yours out.
Billy, do you know what you're gonna do?
I think I know.
All right, guys, well, we've really got to go. Let's get out of here.